Hi folks, in this video we are going to look at a PV diagram which consists of a cyclical process represented by this rectangle, and we are going to learn how to convert that and draw the same cyclical process on a VT graph and also on a PT graph. Would you like to pause the video here and try it on your own? I'm going to give you the solution now. Let's start at point 1. At point 1 the pressure is P1, the volume is V1. So correspondingly, you can find the temperature T1 by using PV is equal to nRT. So let's put that equation out here. We're going to be using this throughout. PV is equal to nRT. So the temperature is T1 at some temperature T1. What we're doing is we are going from 1 to 2. This is a constant volume process called an isochoric process. So the volume is constant, but the pressure is increasing. So if you look at this equation, if you keep the volume constant and increase the pressure, the temperature is going to be increasing. So at constant volume V1, we wish to increase the temperature. So constant volume, we increase the temperature. The process is going to be something like this. By the way, at constant volume, the pressure is doubled. If you look at this equation, if the pressure is doubled, the temperature is doubled. So we go from T1 to 2T1. If this is T1, we go from T1 to 2T1. Let's go from 2 to 3 along the cycle. Here we have a constant pressure process. Pressure is 2P1. So we are plotting V versus T. So V is going to be nRT by the pressure. Pressure is 2P1. So the denominator is a larger number. 2P1 is larger than P1. So the denominator is larger. If you look at this graph, V versus T is a constant times T. Y is equal to mx. So this is going to be a straight line passing through the origin. So it's going to be a straight line passing through the origin. And nr by 2p1 is the slope. And the slope is not very high because the denominator 2p1 is a high value. So we draw a line of low slope which has to pass through the origin. So from here, our graph will be a line that will be like that. And what happens until, how far do I draw this? If you look at this, from 2 to 3, the volume has doubled at constant pressure. That means the temperature will double. So from 2T1, it goes all the way to 4T1. So we draw it all the way to 4T1. Okay, so we draw it all the way to 4T1, and let me make this part of it as dashed just to show you our process starts here from 2T1 and goes to 4T1 along this line, but this line when extended passes through the origin, and the slope of this line is nr by 2P1. So having arrived at 3, we now reduce the pressure at constant volume. Again, the volume is constant, the pressure is going down, which means the temperature is going down. So we reduce the temperature at constant volume. So what will the graph look like? It will look something like this. How far do we go? Well, take a look at this. The pressure becomes half at constant volume, so the temperature becomes half. So it comes all the way down to 2T1. So this is our point. Let's put the points. This is point 1, this is point 2, this is point 3. We have gone from 3 to 4 and 4 back to 1. We have to go back to 1. What kind of a line is that? Well, from 4 to 1, it's a constant pressure. So again, so PV is equal to nRT gives us V is equal to nR. The pressure is constant at P1 times T. Again, the equation is Y is equal to mx. It's a straight line passing through the origin, but now the denominator P1 is less than 2P1, which means the slope is higher. So the slope of this line is going to be greater than the slope of this line. So again, it's going to be a line passing through the origin. And if I had drawn all these things correctly, it would have come up to here. So this is 4 back to 1. So this is what a V versus T graph looks like. 2 horizontal lines and 2 lines when extended passing through the origin. Our last problem for this video is just like problem number 2, except now we are asked to draw the corresponding P versus T graph. As before, we start with point 1, pressure P1, volume V1. So 1 to 2, the pressure increases at constant volume. So if we look at our favorite equation, PV is equal to nRT, we are plotting pressure versus temperature. So pressure is going to be nR by V times T. So along 1 to 2, the volume is constant. So this is a constant number. So y is equal to mx is a straight line passing through the origin. So 1 to 2 is a straight line passing through the origin with a slope of nR by V. So let me start by drawing straight line, something like this. Now let's see. We went from P1, V1, T1. So let's say this is P1 and this corresponding point is T1. Now the pressure doubles. So the pressure goes to 2P1, right? At constant volume. So this is constant. When the pressure doubles, the temperature doubles. So we draw this curve up to 2T1. Process starts here at P1, T1 and goes up to here 2P1, 2T1. So this is 1 to 2. So from 2 to 3, the pressure is constant at 2P1. At constant pressure, the volume doubles. So at constant pressure, the volume doubles, the temperature doubles. So it goes all the way to 4T1. So from here, we draw a constant pressure at 2P1 all the way to 4T1. So this is point 3. From 3 to 4 at constant volume, that means constant slope. Pressure versus temperature is a straight line passing through the origin. It's of the form y is equal to mx. The pressure drops to half its value, so the temperature should come back to 2T1. So this should be a straight line passing through the origin all the way to 2T1 and 4 to 1. Pressure is constant. So pressure is constant. Horizontal line. So that's the last leg of the process. So this is our P versus T graph. That's it for today, folks. See you in the next video. Bye-bye.